Assalamu alaikum. Today we will discuss very interesting problem. We know that most European countries use wine, and wine is the aqueous solution of ethanol, which is mostly 9 to 16%. And uh, ethanol is produced by fermentation process, and for this fermentation process mostly fruits, grains are used. During this fermentation process, methanol is used along with the ethanol. Ethanol used for drinking purpose, but methanol is highly toxic and lethal and can cause blindness if produced in ethanol during the fermentation. If concentration of methanol in the wine is 0.3 molar, that is the borderline which can be used, but greater than 0.3 molar, that is highly toxic. Okay, next question: how methanol is produced during the fermentation? Basically, fruits, grains contain pectin, and methanol primarily originate from pectin. That is the one reason for production of methanol during the fermentation process. And second one, wild yeast or bacteria in the unpasteurized material may produce pectinase and accelerate the methanol release. And sometimes heating raw material during the mashing biomass pretreatment can thermally degrade pectins and generate methanol. Overall, pectin is the main reason for production of methanol. Next, a 100 ml sample collected from police raid of illicit distilled operations was analyzed to contain relative volume of 45 ml of ethanol, 5 ml of methanol, and 60 ml of water. We are asked to calculate the molality, and mole fraction of methanol in the solutions. How we can solve this problem step by step? First of all, we know that density of all liquids are given: ethanol, methanol, and water. Change the volume in the mass, multiply their volumes with their densities. Their volume can be changed into their masses. Next, convert these masses into their moles. We know that moles is the mass over molar mass. Methanol molar mass is 32 gram per mole. Ethanol molar mass is 46 gram per mole. Water molar mass is 18 gram per mole. Okay, next, divide their masses, which we have calculated in first step, with their molar mass. And methanol number of moles 0.1235 moles, ethanol number of moles are 0.771 moles, and number of moles of water are 3.33 moles. Next, we calculate the molarity of methanol. We know that molarity is the number of moles of solute per liter of solutions. Okay, we know that total volume of solution was given in the statement is 100 ml. When we change this volume into liter, that is 0.1 liter. Okay, number of moles of methanol we have calculated in previous step, that is 0.1235 moles. and molarity of the methanol in the 100 ml of solution is 1.25 molar, but borderline of the methanol in the solution is 0.3 molar. That is very high concentration. It means that solution, that wine, is not capable for drinking purpose. Okay, next we can calculate the molality. We know that number of moles divided by the kg of the solvent, okay, for the purpose of molality. And solvent is the water. Water is the 60 gram. When we change the 60 gram into kg is 0.06 kilogram. Okay, then number of moles of methanol divided with the solvent in kg, that is 2.06 mole per kg. That is the molality of the methanol. Next we calculate the mole fraction of methanol. In this first step we have calculated the masses. Second step we have calculated the number of moles. First of all, we sum up all the number of moles of methanol, ethanol and water. For purpose of mole fraction, we must add up all the number of moles. Okay, total number of moles is 4.22, and mole fraction of methanol is equal to number of moles of methanol divided by the total number of moles. That is the 0.0293 mole fraction of the methanol. Hope so you got all the points and all the steps of this numerical. By using this numerical we can find out that the wine sample or ethanol sample which is used for drinking purpose, that is capable for drinking or not. Thank you very much.